DIY. But I will say that, this whole thing is cool because it's just an exotic kind of process there,
Right.
And it reminds me of some materials that we're talking about
Right.
for the space station.
Well,
Looking at you
for the
right now,
space
Joe.
station? What'd you say? Oh, I see what you're talking about. Exotic materials on the space station? Did someone say exotic materials on the space station?
So was it recently when I was talking about the 3D printing in space, that they were 3D printing human organs Yeah, because that's what Bose-Einstein was talking about.
Mm-hmm.
Yeah. Mm-hmm. So this is another example of like just stuff that you can do in space in that zero gravity environment that you just can't quite do on Earth. So, I mean, if people are always wondering, like, what's the point of going up to space and being in zero G, like, there's actually stuff that you just can't quite do on Earth that you have to be up in space to do. And this was one of them. So this is from New Scientist, but they were talking about there's a lab, an experiment on the ISS called the Cold Atom Laboratory, of the CAL. And it was been up there since 2018, but it's designed to create this type of exotic matter called a Bose-Einstein condensate. I put the wrong syllable in the wrong place. And yeah, so it says this suitcase-sized device chills atoms of rubidium and potassium in a vacuum chamber using laser light to slow their movement. It's cooled to nearly absolute zero at negative 273 degrees Celsius, producing a Bose-Einstein. I keep wanting to say Eisenstein for some reason. Condensate. But anyway, it's a fifth state of matter following solids, liquids, gases, plasma. Supercooled gas is no longer behaves as individual atoms and particles, but rather as an entity in a single quantum state. So it's basically taking a piece of matter and making it all quantum. A Bose-Einstein condensate. And the problem with creating it on the ground is that as soon as you make it, it tends to kind of go away because of gravity. Gravity kind of pulls the atoms in a direction that causes it to come out of that quantum state. But in space, they're able to do it. And it sticks around for a few seconds so that they can actually study it and learn some more about it.
Whoa. That's crazy. I love that kind of stuff, the stuff that there's so many of those little things that plug a couple more things into the giant puzzle of life, and just help us understand physics better, and so many that just they're the little pieces that solve. Yeah, that's super cool. I had not heard about that.
Yeah, so it says right here, it gives you a macroscopic sized quantum mechanical object.
Jeez.
So
that's really cool.
Kind of hard to put that into perspective, but yeah. So it's basically making the entire molecules of atoms function as like a proton or a electron or something.
That is, that just sparked something, because I think we talked about it before, but like gravity is something we just have no answer for here on Earth. Mm-hmm. There's no way, like we can make things hot, we can make them cold, we can shield them, we can play with magnets and stuff, but we just don't have an answer for gravity. There's no anti-gravity capability whatsoever that we currently have that's, been released to the public. So here up at the ISS or, in space, used to say, we have a thing. We have a way to remove gravity from experiments and from equations. And so that, man, I mean, that's kind of deep and but I'm sure there's some physicists out there wondering, just going, oh, well, if we could just take out gravity from this, we could do all this other stuff. And,
that is my hope.
Sign.
That is my hope in my lifetime, that we really understand the entire, all of that, and have kind of something that is the opposite of, the full grasp of how gravity actually works, just to be able to be oh, we'll just need to do this and it whoop, off, or whatever. I really hope that we figure that out someday.
Yeah. So this says that the team found that about half of the atoms form into a halo-like cloud around the main body of the Bose-Einstein condensate. On the ground, these atoms would simply fall due to gravity, but up there they remain in a cloud state, so you can actually study it. Yeah.
Wow.
They want to probe ripples in space-time called gravitational waves by monitoring disturbances in the movement of the atoms. So this can actually help detect gravitational waves. without having to create, 20-kilometer long
Lasers.
at LEGO.
Wow.
Yeah.
That's so cool.
It's funny because like the 3D printing thing that we talked about before, I don't know why I'd never really dove into like the advantages of microgravity when it comes to scientific experiments and stuff like that. And especially when it comes to construction and like being able to actually build stuff that you just can't build down here on Earth. And this is kind of one of those things, you know?
Yeah.
It's cool.
That's really cool.
Hey guys, thanks so much for watching this clip from our show. If that's just not enough for you and you want to watch the full episode, you can go to olfpod.com/YT.
And if you want more from us, you can consider becoming a Patreon member. You'll get early access to episodes. You can join our awesome community. You can actually watch us record live and get your name in the credits by going to olfpod.com/Patreon.
So thanks everyone for watching. Check back every Friday for new clips here and new episodes on the main channel.
Thanks, everybody.